dear Shellstars. How are you all? Students, yesterday we have done till question number 6 of exercise 6.5. So today we are going to proceed further with the same. Question number 7 of your exercise 6.5 is find both the maximum and the minimum values of the function 3x raised to power 4 minus 8x cube plus 12x square minus 48x plus 25 on the interval, that is closed interval 0, 3. So as we used to proceed, first we are going to find the first order derivative, then substituting that derivative equal to 0. So whatever the value of comes out to be, those will be our critical points. Then we are going to check the value of the function on all the points that are given to us. So here we are starting with first order derivative of the given function is 12x cube minus 24x square plus 24x minus 48. Here 12 is common and the factors of the given derivative comes out to be x minus 2 and x square plus 2. So your first order derivative reduces to 12x minus 2 into with x square plus 2. So when we substitute both the factors equal to 0 to find the critical point, students, we can see that one factor gives the x value as 2, whereas from the other factor we are getting x square equal to minus 2, which is not a real root. So we are not going to find these points. So only we have x equal to 2 as a critical point, which also belongs to our closed interval. So now we are calculating all the values. Now first thing is at f value at 2. So on substituting x as 2, we are getting the value on simplification as minus 39. So the values of f are calculated at 2, 0 and 3. At 2 we are getting the value as minus 39. At 0 we are obtaining 25. Whereas at 3 we are getting the value as 16. Students, it is clear from here that we are getting the maximum value as 25, which we are getting at 0. Whereas we are getting the minimum value as minus 39, which is obtained at x equal to 2. Next, question number 8 is at what points in the interval 0, pi by 2 pi does the function sin 2x attain its maximum value? So here we have to find only the maximum value. So same step, first we will find the first order derivative, that is 2 cos 2x, substitute that equal to 0. So cos 2x equal to 0. Students, we know that from 0 to 2 pi there will be 4 points where cos is going to take the value as 0. So those points are pi by 2, 3 pi by 2, 5 pi by 2 and 7 pi by 2. So 2x is equal to these values. So this implies x will be pi by 4, 3 pi by 4, 5 pi by 4 and 7 pi by 4. And also the end points of the interval 0 to 2 pi. So we are finding the value of the given function, that sin 2x at all these 6 points. 6 points are pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4, 0 and 2 pi. So amongst them, at whichever point we are getting the maximum value of sin 2x, that will be our maximum value corresponding to that point. So at all these 4 points we are finding the value of the function, that is sin 2x. At pi by 4 we can see we are getting the value as 1. At 3 pi by 4 we are getting the value as minus 1. At 5 pi by 4 again 1, and at 7 pi by 4 minus 1. We know that sin 0 is 0 and sin 2 pi is again 0. So that means our maximum value is 1 and it is occurring at pi by 4 and 5 pi by 4. If they have asked for the minimum value, then its minimum value is occurring at 3 pi by 4 and 7 pi by 4 and minimum value is minus 1. Question number 9 is what is the maximum value of the function sin x plus cos x? Again we will find the first order derivative and substitute that equal to 0. So cos x plus sin x, first order derivative is cos x minus sin x. Sin x derivative cos x and cos x derivative minus sin x. On solving this, we are getting tan x equal to 1 and tan take value 1 at pi by 4, 5 pi by 4 and so on. These are the values where tan takes the value 1. So here we are going to check for the second order derivative. So second order derivative is minus sin x minus cos x, that is minus of sin x plus cos x. So it is clear that it is negative whenever cos x plus sin x is positive, and we know that the value of sin x and cos x are both positive. Also we know that sin x and cos x both are positive in the first quadrant if we talk about pi by 4. So that means its second order derivative at pi by 4 is minus root 2, whereas in the second quadrant one is negative and the other is positive. So its value reduces to root 2. Hence the maximum value is root 2 and minimum value is minus root 2. Now the 10th question of your exercise 6.5 is find the maximum value of this function, that is 2x cube minus 24x plus 107 in the interval 1, 3, and find the maximum value of the same function in the another interval, that is the closed interval minus 3 to minus 1. Students, we will proceed here in the similar way as we have done in the previous question, that is from question number 6 to question number 9. First we are going to find the first order derivative. Substitute that derivative equal to 0. We are getting the value of x, whatever the value of x lies in the interval, that will be considered, and finding all the values of the function at all these different points. So do this as your homework. That's all for today, students. Do revise what we have done in the class today. Do your homework also, and you have any query regarding the topic, please feel free to ask on the Google Classroom. Thank you, take care and have a great day ahead.